So let's do this question. Find median from data stream. As you probably would know, the median is the middle value in an ordered integer list. But for this question, we're not given an integer list. We're given just an add num function. So how do we find the median if you're only given add num? Well, the input is a bunch of calls to these functions, and at any point they could call find median given the numbers they've given us so far. So I guess you could just keep track of a set or something, and whenever they call add num, add to the set. But there could be duplicates, so you could maybe use a multi-set or just a vector. If you use a multi-set, you could add it in, and multi-set's already sorted for you. So when you go find the median, you just get the size and find the middle one. Iterate through until you find the middle one. You can't find it in constant time because it's implemented as a tree. The alternative is if you use a vector, and every time you add a num, you add to the vector and then you sort the vector, which is n log n for a single add num, and the other one was just n for the find median. But let's see, there are at most 5 times 10 to the power 4 calls to add num and find median. So that's not good, because that would mean we have a n squared, at least n squared for both those approaches. We need to find a faster approach. And one way is to keep track of 2 sets. So we keep track of the median, and then you keep track, and whenever you add a number, you either update the median to be the value before or after. That can't be done with one set, because if you add a number to a set or something like that, you can't compare values. Can't compare the positions of the iterators in the set. I know definitely that the value of one iterator is less than the value of the other iterator. That only works for contiguous arrays. So we need to keep track of 2 sets, 2 multi-sets, where the left set contains all the elements less than or equal to the median, and the right multi-set should be everything greater than the median. So for example, if we have a 2, 3, 4 here, we add say 3 here. In this case, this is okay. There's an odd number of elements, and so the median in this case is going to be the greatest element of the left multi-set, and that's fine. If we add the 2 now, so we see that the 2 is less than the median, or less than the greatest element, less than or equal to the greatest element of the left multi-set, then we add it to the left side. We see that the 2 arrays are unbalanced, because the median is 2 plus 3 divided by 2, so 2.5. We actually want the 3 to be in here, not there. So we can do a shift to achieve that. So whenever it's odd, basically, whenever we have an odd number of elements and we insert to the left side, we need to shift to the right. But what if we inserted the 4 first? What if we inserted 2 and then we inserted 3 and then we inserted 4? So if it's even and then we insert a number into the right set, that will cause it to be uneven, so we need to shift to the left, causing it to look like this. And that's the general idea. So we can try and implement that. I've already defined a multi-set left and right here. When we add a number, we also have to take care of the fact that if there are no elements in the set, there is no median to compare with. So we could just say if the left.empty, if it's empty, then add it to the left set. Or if the number is less than the greatest element of the left end. The left.end is the one beyond the end, one beyond the last element, so we need to decrement that. Then we can insert to the left set, like that, num. Now the case was, because we're inserting to the left, only when it's odd, size of the left set is greater than the right set, so doing this would cause it to be uneven. So if it's odd, let's keep track of the number of elements here. So left.size plus right.size. If n modulus 2 is equal to 1, then we need to shift to the right. Shifting to the right, so let's grab the greatest element of the left, like that. No need the brackets actually. And then we could insert it to the right before we delete it. Okay. So right.insert the value start it, and then erase it from the left. Cool. In the case where we insert it to the right, we want to shift to the left only if the number of elements is even. So right.insert number. Like for example, if we have 3, you have 3, 2, 3, and we insert a 4, you definitely need to shift to the left by inserting a 3 here and then erasing it from this one. So if n modulus 2 equals 0, and grab the smallest element of the right set, do the left.insert value and right.erase that. Okay. Now the median would just be, if it's odd, the greatest element of the left set. Otherwise, if it's even, it will be the average of the greatest element of the left set and the least element of the right set. So if, okay, we have to calculate the number of elements. If n modulus 2 is equal to 1, so if it's odd, then just return left.end minus minus, and let's also dereference it. And because we're returning a double, let's cast it to a double. Else return. So let's cast basically this whole thing again. Plus double of the rights begin and divide the whole thing by 2. See if that works. This should be just equals. Okay. Oh, this should be begin. Oh, there we go. Yeah, it should be begin because we need the least element of the right set, not the, yeah. That is very slow. Try and improve it next time. But yeah, that's the basic idea of how to do it.